So a third, and in this case final, way of solving a system that we're actually going to look at is elimination. It's called the elimination method. Okay? And you've probably seen this before, but this is just meant to be just a little bit of a refresher. Okay? With elimination, it's kind of a 5-step process, and I like to use the acronym SMASH to help me remember it. The first S says set up the equations. That means that my x's are lined up, my addition subtraction signs are lined up, my y's are lined up, my equal signs are lined up, and my answers are lined up. Okay, so I want everything lined up perfectly up and down. Okay, then M, multiply to make opposites. If necessary, this isn't always necessary. Sometimes you'll multiply 1, sometimes you'll multiply 2 of the equations, and sometimes you won't have to multiply any at all. Okay? When I say the word opposites, just really quickly, -6 plus 6, -5 plus 5, -1 plus 1, 3 plus -2, no, dilate. Whoa, holy cow, that would have been bad. 3 plus -3. Okay? All of those equals 0 because opposites cancel each other out. We are looking for additive inverses, a little vocab. Okay? By getting those 3, -3, 6, -6, and so on, we are now ready to add down to eliminate. There's a reason this is called the elimination method. To eliminate a variable. Okay? Add down to eliminate a variable. Solve for that variable. Substitute that variable. And solve to get the other variable. Solve, substitute, and solve. And then finish by, have I answered the question? I mean, you should always ask yourself that. Did I write the ordered pair? Have I answered the question? Okay. Let's look at an example. So, here we go. SMASH. Set up the equations. Now, if we look at this, we are set up. X's lined up, plus and minus lined up, Y's lined up, equal signs lined up, other nonsense lined up. Set up the equations. Remember, for substitution, we like them kind of spread out. We like to bring this one, all of that one, over there. And we like to have them set up in kind of a column format. Here we want them stacked. Then, M, multiply to make opposites. Opposites are positive and negative of the same number. Additive inverse and the number. A number and its additive inverse. That means one of them has to be negative. As soon as I see that I have a +6 and a -3, one of each, that's like the way to do it. That's what we're going to zero in on because the negative is already in there. If it wasn't there, we'd kind of have to force it in with our multiplying, but here we're good to go. Okay? So I'm going to turn this into an opposite. And the way I'm going to do it is I'm going to try and make both numbers, in this case a 6. Okay? Because it's easy for me to change the 3 into a 6. Well, in order to do that, I'm going to multiply this bottom equation by 2. In doing so, my 5x is a 10x. My 3 minus 3y is now a minus 6y. And my 88 is 176. We can already see that we now have a minus 6y that's going to cancel with our positive 6y. So this top equation is just going to come over on its own. Okay, so now it's set up. Now we need to add down. We've done S, M, and now we're on A. Add down. 2x and 10x, just collect in like terms. That's 12x. 6y and minus 6y. This is the elimination method. The y's have been eliminated. Okay, and then -8 and 176. 168. Why does that sound funny? Nope, that's right. 12x equals 168. Then solve, substitute, solve. So we have to finish and actually get what x is here. X is 14. Solve, substitute, solve. Okay? So we've done one of the solves. Now we substitute. This 14 is going to go into x. Okay? You can plug it into this equation, this equation, this equation, or this equation. You have choices. I like to plug it into right here because then I have all the work down below, or the place down below to show my work at. That's just me. So, wiser and smarter now, we know what x equals. We know x is 14. So we've done the solve. We've done solve. We've done substitute. Now we're going to solve. So 5 times 14 is 70 minus 3y equals 88. Subtract 70 from both sides, minus 3y equals 18. Divide both sides by negative 3. And y equals negative 6. Now, have I answered the question? Did I write my answers in ordered pair? Well, in this case, my ordered pair is 14, comma, negative 6. Now, I have answered the question. Okay? So, set them up, multiply, add, solve, substitute, solve, and then have I answered the question. So now look at this one. You can do this one. I know you can. Okay? Give it your best shot. If you get stuck, unpause, and then watch and let's go through it. If you've got it, then watch and check and make sure you got it. Here you go. Okay, so how'd you do? How did you do on this one? Hopefully you got the right answer. Now let's take a look. Okay? In this case, we need to set up. The setup is done. So now it's multiply to make opposites. Now you have a choice here. Make the x's opposites or make the y's opposites. I'm going to tell you right now, I'm going to do the y's. The reason I'm going to do the y's is because of this right here. I have the plus and the minus. That part of the inverse is locked up. So now all I really have to do is just multiply. I'm going to multiply the top one by 5 and the bottom one by 3. That's going to turn both of the y coefficients into a 15. Okay? So, in doing that, 5 times 5 is 25. 5 times negative 3, negative 15. 5 times 42. Well, 10 times 42 is 420. Half of that, since I'm only multiplying by 5, is 210. And the bottom one, 8 times 3 is 24. 15y. And this is where calculators come in handy, 84. Great. Do we have opposites? If you do not have opposites, something will not be eliminated and you're stuck. So check right now. Yep, I got a positive 15, I got a negative 15. Miss Visto, I am ready. Well, good. Let's add down now. Straight down. 25 plus 24 is 49. X. Negative 15, positive 15, that is eliminated. That's gone. Okay? That's the goal. There's a reason this is called elimination, and there's a reason the other one is called substitution, and there's a reason the third one's called graphing. Mathematicians are boring. Little sidebar here. They name it by what they see. If a mathematician was going to call something an adjective, they would never use the word adjective. They would call it like it's a describer. And nouns would be things. And verbs would be actions. Okay? Math people are boring, not creative, just going to call it like they see it. This something is eliminated, it's elimination. Substitution, going to do some substituting. Graphing, going to draw the graph. Okay? So something better be eliminated if we're using the elimination method. Okay? So something has been eliminated, we're using the elimination method. Now we're going to finish solve, substitute, solve. So I'm in the solve. X equals 6. Boy, after all that, we got a nice, cute number for x. So the first step in the solve is done. Now we got to do the second step, which is the substitute. So x is now 6. I'm going to come over here, and I'm going to replace my x with a 6. Now I'm just picking this equation because I like that I have room underneath it to show my work. Truly, that is the only reason. I have 4 completely different equations I could have picked, but I picked this one. Okay? X equals 6, so I'm going to do my substitute. 8 times 6 is 48. 6 and 8 went on at 8. Subtract 48 from both sides. Divide both sides by 5. And y equals -4. This is the third part. Solve, substitute, solve. Have I answered the question? Have I done what I'm supposed to do? Have I written it as an ordered pair? Well, not yet, but I'm about to. 6, -4. Is that what you got? I really hope it is. Okay? Now, you now have 3 methods for solving, and each one is good in its own time. And that's something you need to start to realize. As you practice these two, start figuring out, hey, which one do I like? Hey, is this a good option? Hey. Okay? Figure these things out. In the meantime, this is the elimination method.